The research paper on open information extraction, OI, highlights the need for objective benchmarks to evaluate the performance of OI systems. Despite the development of numerous OI systems, current benchmarks, such as BenchIE, have limitations including errors, omissions, and shortcomings. To address these issues, the authors propose BenchIE FL, a new OI benchmark that enforces the principles of BenchIE while reducing errors and limitations. BenchIE FL allows for more accurate evaluations of OI extractors and provides insights into their capabilities. The authors have manually re-annotated BenchIE, correcting frequent errors and inconsistencies, and developed a new matching function to capture more valid extractions. This results in more concise, precise, and pertinent annotations. The paper compares 7 OI extractors, including neural and non-neural systems, showing that the state-of-the-art systems are not necessarily the best. It also demonstrates that the scores of extractors on BenchIE FL exhibit a stronger correlation with their performance on downstream tasks. Open information extraction, OI, models can be categorized into sequence-to-sequence or sequence tagging techniques. Sequence-to-sequence models, such as IMAGE-IE and M2OIE, output the original sentence one word at a time, utilizing copying and attention mechanisms. Neural tagging models, like OpenIE6 and CompactIE, focus on identifying relations initially and then tagging other words as arguments related to those relations. These models are typically trained on bootstrapped data from previously released extractors, selected with confidence scores and heuristics. The first complete OI benchmark, OI 2016, was created by automatically transforming 2 question-answer-driven semantic role labeling (QASRL) datasets into a benchmark comprising 3,200 sentences and 10,359 extractions. The matching function used by OI 2016 matches an extraction and a reference tuple if the grammatical head of both their arguments and their relation are the same. However, Lachelle et al. 2019 identified limitations in the conversion involved in OI 2016 and its matching function, demonstrating that it is straightforward to attack this benchmark with a dummy extractor. Wire 57, a benchmark made up of 57 expertly annotated sentences from Wikipedia and Reuters, uses token-level scoring to measure precision and recall. However, Wire 57 has been criticized for its small size. CARB, another benchmark, uses crowdsourcing to manually annotate sentences, releasing a reference of 2,714 tuples from a subset of 1,200 sentences from OIE 2016. Gashtiovsky et al. 2022 criticized CARB's scoring function, proposing a conservative exact matching function that only counts extractions identical to an annotated tuple. The authors introduce the synset principle, annotating all possible formulations of a fact in a single synset or cluster, allowing for exact matching. They manually annotate 300 sentences of the original OI 2016 dataset, resulting in 1354 clusters. These benchmarks yield different conclusions regarding the best performing extractors due to differences in annotation principles, text corpora, and matching functions. Recently, Pei et al. 2023 made recommendations for assisting in deciding the best neural extractor for a given downstream task, and which benchmark's characteristics better correlate with it. However, there is a need for sound. In the realm of open information extraction, OI, errors in annotations are categorized into 5 distinct types: missing fact, false fact, irrelevant fact, double annotation, and double meaning. These error types are exemplified with examples from a sample of BenchIE, where square brackets indicate optional words when matching facts. A missing fact occurs when a fact in the reference is not present in the annotated clusters, such as when 2 hydrophobic particles come very close, but the clathrate-like baskets surrounding them do not merge. A false fact is a fact in the reference that is false or not necessarily implied by the sentence, for instance, stating that hydrophobic particles can come very close without mentioning the merging of surrounding baskets. An irrelevant fact lacks relevance due to missing context or information, as seen in the example of making bombs on the outskirts of Murray, Utah, without providing relevant context. Double annotation occurs when 2 clusters have at least one formulation that expresses the same information, whereas double meaning arises when a single cluster has at least 2 formulations that express different information. Table 1 illustrates these error types with examples, and Table 2 shows the frequency of these error types in the 50 sentences of B50 in BenchIE. The results indicate that more than half of the sentences have one or more missing facts, while about a third of the sentences contain irrelevant or false facts. This highlights the need for more thorough annotation of the original sentences, motivated by solid guidelines that are typically lacking in OI tasks. The matching problem in OI is also addressed, where many cases of valid extractions were not matched by the exact match used in the BenchIE benchmark. To address this, a new matching function is proposed to capture more matches between extracted and annotated tuples. Finally, guidelines for annotation are discussed, emphasizing the need for universally accepted principles to guide annotation and make OI output useful for downstream tasks. The authors propose 4 principles for annotating sentences with informative tuples, ensuring accuracy and comprehensiveness. The principle of informativity dictates that tuples contain specific information, avoiding generalities. For instance, Alex is now living in Cologne is an informative tuple, whereas Alex is now living is not. The principle of minimality requires that each tuple be minimal, meaning it cannot be broken down into multiple distinct tuples. For example, the group was created in 2020 by 3 people is not a minimal tuple, as it combines 3 separate facts. The principle of exhaustivity ensures that the set of tuples for a given sentence covers all pieces of information expressed in the sentence. This is exemplified in the annotation of all types of writing that he has done in separate clusters. The principle of relation completeness states that relations should be complete, meaning that the information in the arguments does not change the core meaning of the relation. For instance, Tokyo's population is over 13 millions is a complete relation, whereas Tokyo's population is over 13 millions is not. In addition, the authors introduce the principle of inference, defining inferred tuples as facts implied by the sentence but not explicitly stated. Inference should be carried out to capture useful information for downstream tasks, but limits should be set to avoid complex reasoning or external knowledge. For example, Mark's own label is Frazzy Frog Music is an inferred tuple. To facilitate the annotation process, the authors provide matching guidelines to determine which extracted tuples should match with which annotated clusters. While exact matches are obvious, the authors highlight nuances that exist and provide principles to illustrate these nuances, ensuring accurate and comprehensive annotations. The principal sentence annotations in BenchIE FL, a re-annotated version of the corpus, emphasize relation specificity, word choice, and level of detail. For instance, the relation was thrown is less precise than was thrown out of, which significantly changes the meaning of the argument. Similarly, syntax errors or word choices can affect the sense of an extraction, but they are acceptable if they do not alter the overall meaning. The level of detail principle is also crucial, where extractions combining information from more than 2 clusters are considered too noisy for a downstream task. Statistics comparing BenchIE and BenchIE FL show that BenchIE FL has a higher average number of clusters per sentence due to including inferred information and following the minimality principle. It has fewer formulations per cluster due to the emphasis on relationship specificity and not relying on an exact match function. The mean lengths of the relations are equivalent, preserving the specificity of the relations. A manual evaluation was conducted to validate the annotations. 2 other annotators with over 20 years of expertise were presented with sentences from B50 and their annotations from both sets of annotations. This experiment aimed to ensure the accuracy and reliability of the re-annotated corpus, BenchIE FL. The validation of the new Open Information Extraction (OI) benchmark, BenchIE FL, involves comparing its annotation guidelines with those from BenchIE, another prominent OI benchmark. The validation process includes asking annotators to identify errors based on criteria such as exhaustivity, minimality, and relation completeness. The results demonstrate that BenchIE FL annotations have fewer errors than BenchIE annotations, with a moderate agreement between the 2 annotators. Additionally, the paper introduces a new matching function for evaluating OI system performance, which includes heuristics for alternative formulations, level of detail, and punctuation. These heuristics improve the F1 score compared to the exact matching function used in BenchIE, highlighting matches due to differences in detail or punctuation. The system extraction and annotation cluster match is a crucial component in open information extraction (OI) systems, where the performance of various matching functions is paramount. Among these, the M plus AF plus LOD plus punc function stands out for its optimal performance, making it the default choice. This function combines entity matching, attribute filtering, logical dependency, and punctuation-based matching to achieve high accuracy in extracting relevant information. The significance of OI extractions is further demonstrated in downstream tasks, such as assertion-based question answering, complex questions answering, and knowledge-based population. In these tasks, the quality of OI extractions directly impacts the system's performance. The scores of different systems on these tasks are presented, highlighting the importance of evaluating OI extractions in practical applications. The results underscore the need for efficient computation in certain tasks, which remains a limitation of current OI systems. Future work should focus on addressing this limitation, as well as exploring new approaches to improve the accuracy and efficiency of OI extractions. By acknowledging these challenges, researchers can continue to advance the field of OI and its applications in natural language processing and knowledge graph construction. A comprehensive analysis of various open information extraction (OI) systems is presented, evaluating their performance across different benchmarks and downstream tasks. To facilitate a more meaningful comparison of off-the-shelf extractors, new annotated resources, BenchIE FL and BenchIE FL Match, are proposed. These re-annotated OI corpora feature improved guidelines for tuple annotation and candidate extraction matching, highlighting the competitiveness of older rule-based systems in the field. The study explores the correlation between system scores on benchmarks and their performance on three varied downstream tasks, revealing that BenchIE FL exhibits the highest correlation. This suggests that BenchIE FL is a better indicator of real-world extractor performance, making it the preferred reference for guiding OI system choice and influencing system development. An examination of system rankings across benchmarks reveals significant differences between neural models and rule-based systems. While neural models tend to copy large chunks of input texts, often resulting in non-informative tuples, rule-based systems demonstrate a more competitive performance. The limitations of neural systems are further analyzed in the appendix. The discussion concludes by identifying avenues for future work, including the annotation of additional sentences and refinement of the evaluation methodology. This comprehensive comparison of existing benchmarks and proposed improvements contributes to the advancement of OI systems, guiding future research and development. The authors acknowledge the limitations of BenchIE FL, a benchmark for open information extraction (OI) systems. One major constraint is its limited size, which restricts its utility in training models. Although the annotations are considered more rigorous than previous ones, the possibility of errors cannot be ruled out. The proposed matching function, despite outperforming the exact match function of BenchIE, lacks flexibility, and alternative features or methods could potentially outperform it. Additionally, BenchIE FL, similar to most OI benchmarks, is only available in English, which limits its applicability. The authors recognize the potential for improvement in the matching function, highlighting the need for more flexible and robust approaches. They also acknowledge the language bias of BenchIE FL, emphasizing the importance of developing multilingual OI benchmarks. By acknowledging these limitations, the authors provide a realistic assessment of BenchIE FL's capabilities and highlight areas for future research and development. The authors' candor about the limitations of BenchIE FL underscores the need for ongoing refinement and improvement in OI benchmarks. By identifying potential avenues for future work, they pave the way for the development of more comprehensive and robust OI systems. The authors present a comprehensive review of existing research in open information extraction, OpenIE, citing 17 papers published between 2007 and 2023. These papers cover various aspects of OpenIE, including iterative grid labeling and coordination analysis, memory-based joint open information extraction, fine-grained benchmarking, and quasi-knowledge graphs for complex question answering. Other papers focus on knowledge-based population, comparative empirical analysis of OpenIE systems, multilingual open information extraction, large-scale datasets for supervised open information extraction, and creating large benchmarks for OpenIE. The authors also cite work on OpenIE as an intermediate structure for semantic tasks, assertion-based question answering with question-aware OpenIE, and TextRunner for open information extraction on the web. Additionally, they reference a span model for OpenIE on accurate corpora. These papers collectively demonstrate the breadth of research in OpenIE, highlighting the importance of developing more accurate and efficient OpenIE systems for various downstream applications. This section delves into the implementation details of various systems and benchmarks employed in the research. The systems compared include Reverb, Clause.IE, Mini, Image.IE, OpenIE 6, M2O.IE, and Compact.IE. These systems were run on an Apple M2 processor, with most experiencing dependency issues and requiring significant effort to function as expected. Image.IE proved to be the slowest system, needing over 4 hours to process the CARB test set. The benchmarks used in the research are Wire57, a small, expertly annotated corpus of 57 sentences that uses a token-level matching function. CARB, a crowdsourced annotation of 1,200 sentences with a token-level scoring function. And BenchIE, which uses clusters or synsets to group all formulations of a single fact, allowing for an exact matching function. The research also introduces the concept of alternative formulations to match extractions to annotations when an exact match does not show correspondence. This includes identifying 2 cases where alternative formulations can be generated safely. In extractions with the relation is and in those where an argument contains the token, and. Candidate extraction pairs are generated from sample annotations and matched with reference clusters. When a candidate extraction doesn't exactly match a reference cluster, alternative extractions are obtained through rewriting pairs. Credit is given to the original extraction if one of the alternatives exactly matches the reference. To avoid overly rewarding extractions that combine information and don't respect the minimality principle, only the first matching alternative and its associated cluster are considered for precision and recall computation. The authors provide examples of rewriting pairs, such as is, and, along with their corresponding alternative formulations. Inferred clusters, which differ significantly between their annotation and BenchIEs, are handled by presenting a modified version of their annotation set. In this modified version, inferred clusters are transformed to use only words present in the original sentence, referred to as light inference. Clusters that cannot be modified as such are removed, referred to as heavy inference. This modification enables a fair comparison between the 2 annotation sets. The use of inference in both annotation sets is also discussed, with statistics provided regarding the modification. This approach ensures that the evaluation of extraction performance is accurate and reliable, by accounting for the variability in inferred clusters between the 2 annotation sets. By considering alternative extractions and handling inferred clusters, the authors aim to improve the precision and recall of information extraction systems. The internal frame backpack, invented by Greg Lowe in 1967, serves as a metaphor for recent innovations in neural systems for information extraction. These systems tend to produce longer, less precise extractions compared to rule-based systems, as evidenced by Table 15. This is hypothesized to be due to neural systems being trained on non-minimal extractions. In order to evaluate the performance of these systems accurately, the experiment's modifications for downstream tasks were crucial. This included re-annotation of the web assertions dataset and adjustments to the scoring procedure for the CQA task, as detailed in Table 16. These modifications aim to ensure a more accurate evaluation method, which is paramount for better system performance. The discussion emphasizes the importance of precise extraction and accurate evaluation in neural systems. It highlights the need for further research into improving the precision and efficiency of these systems, particularly when compared to rule-based approaches. The passage also underscores the significance of understanding the relationship between training data and system performance, suggesting that a shift towards minimal extractions could potentially enhance neural system accuracy. Overall, the refinement of neural systems for information extraction is an ongoing process that requires careful consideration of both the training data and evaluation methods. By focusing on precise extraction and accurate evaluation, Researchers can work towards creating more efficient and effective systems that outperform their rule-based counterparts. The evaluation of two annotation systems, BenchIE and KnowledgeNet, for extracting information from sentences is conducted through various proxies. These proxies identify errors and inconsistencies in the annotations, including double annotation, double meaning, and false, irrelevant, missing facts. The KnowledgeNet corpus, containing over 7,000 sentences, requires significant computational resources to process. The annotations from both systems are discussed, highlighting differences between them. The double annotation proxy reveals more errors in BenchIE's annotations, with the same fact represented in two distinct clusters, whereas KnowledgeNet's annotations are more accurate and correctly group information. The double meaning proxy shows similar trends, with BenchIE's annotations having more inconsistencies. The false, irrelevant, missing facts proxy indicates that BenchIE's annotations are missing or irrelevant facts compared to KnowledgeNet. This suggests that KnowledgeNet provides a more comprehensive set of annotations. The table comparing the number of sentences with at least one cluster identified by each proxy reinforces the idea that BenchIE's annotations contain more errors and inconsistencies. The analysis of proxies for annotation errors and differences between BenchIE and BenchIE FL reveals significant discrepancies. Double annotation errors are more prevalent in BenchIE, with 135 instances compared to only 5 in BenchIE FL. The double meaning proxy indicates that BenchIE has 55 errors, whereas BenchIE FL has 26. This suggests that BenchIE FL's annotation is more accurate and precise. In terms of false, irrelevant, or missing facts, BenchIE FL has a higher count of 68, while BenchIE has 17. This indicates that BenchIE FL's annotation is more comprehensive and includes more relevant facts. An examination of specific examples shows that BenchIE often includes irrelevant or false facts, whereas BenchIE FL focuses on the actual facts present in the sentence. The examples of extractions from all 7 tested systems on a single sentence, as shown in Table 20, further emphasize the variability in annotation quality among the systems. Table 21 highlights the differences between BenchIE and BenchIE FL's annotations, revealing that BenchIE FL's annotation includes more clusters due to the inclusion of inference and adherence to the minimality principle. This results in a more detailed and accurate representation of the facts within the sentence. BenchIE, a judicial entity, has handled a diverse range of fraud cases, encompassing both direct and indirect taxes, as well as transnational crimes such as drug smuggling and money laundering. Additionally, BenchIE has addressed violations of UN trade sanctions. Notably, Dr. Jagan's participation in a strike and Grainer's treatment of a prisoner are also examined, underscoring the personal involvement of key figures in these cases. The breadth of BenchIE's jurisdiction is a critical aspect, as it demonstrates the entity's capacity to tackle complex, multifaceted fraud cases. The technical and legal implications of these cases are far-reaching, with significant consequences for individuals, organizations, and governments alike. In the context of direct and indirect taxes, BenchIE has navigated intricate legal frameworks to prosecute fraudsters. The entity's handling of drug smuggling and money laundering cases has required coordination with international law enforcement agencies, highlighting the transnational nature of these crimes. Furthermore, BenchIE's enforcement of UN trade sanctions has significant geopolitical implications, as these sanctions are designed to curb the proliferation of weapons of mass destruction and promote global security. The personal involvement of key figures, such as Dr. Jagan and Grainer, underscores the human dimension of these cases, emphasizing the importance of accountability and justice. This research highlights the critical role of entities like BenchIE in combating fraud and promoting global security, while also shedding light on the technical and legal complexities that underlie these efforts. A comparative analysis of 7 information extraction systems is presented, showcasing their capabilities in extracting relevant information from a text describing John Crozier Jr., an early aviation pioneer. The systems, Reverb, Clause.IE, Mini, Image.IE, OpenIE 6, M2O.IE, and Compact.IE, extract various relationships and entities from the input text, including John Crozier Jr.'s role, his attempt to build a human-powered flying machine, and his demise in a feud. The extracted relationships and entities are presented in a tabular format, revealing each system's strengths and weaknesses. Reverb and OpenIE 6 extract detailed information about the flying machine, whereas Clause.IE and Mini focus on relationships between entities. Image.IE and M20IE provide a comprehensive view, extracting both entities and relationships. Compact.IE extracts general information about John Crozier Jr. and the feud. A concise summary of the extracted information is provided in Table 20, allowing for a direct comparison of the capabilities of each system. This analysis has significant implications for developing more accurate and efficient information extraction systems in the future. My Classical Way, a landmark album in the music industry, was released on September 21, 2010, under Mark's own label, Frazy Frog Music. This release is significant not only for its historical context but also for its association with Mark's music endeavors. The album's release date and label are annotated by BenchIE and BenchIE FL, providing a detailed account of the album's context and its relation to Mark's musical career. The content is structured into several clusters, each highlighting different aspects such as the release date, the label, and Mark's ownership. This structure serves as a reference for researchers and stakeholders interested in the album's historical context and its impact on the music industry. In addition to the release details, the page also discusses the significance of Frazy Frog Music as Mark's own label. This label serves as a platform for Mark to showcase his unique blend of classical and contemporary music styles, which has garnered attention from both critics and fans alike. The annotations provided by BenchIE and BenchIE FL offer insights into the album's production process, distribution, and reception. These annotations are crucial for understanding the album's place within the broader context of the music industry, as well as its contribution to the evolution of classical music. The refined version of the content maintains the technical accuracy and depth of the original text while condensing it into a concise and accessible form suitable for voiceover narration. This summary is designed to engage expert researchers and stakeholders in the music industry, providing them with a comprehensive overview of My Classical Way and its significance in the classical music genre. This section of the research paper outlines the annotation guidelines for an open information extraction task, focusing on principles that determine which facts should and should not be annotated. The guidelines are structured into four main categories: number of arguments, informativeness, minimality, and exhaustivity. Firstly, the number of arguments principle dictates that all tuples must contain between 1 and 2 arguments. Extractions with more than 2 arguments can be split into more compact extractions, as demonstrated by the first example. In some cases, tuples may only have a single argument, such as in the second example where XXX is used for convenience. Secondly, the informativeness principle requires that annotated tuples must contain relevant information expressed in the sentence. Tuples must be informative and relevant, avoiding generalities or empty words that convey no information. For instance, the fact that someone has written is not relevant unless it is specific to the context of the sentence, as shown in the third example. Thirdly, the minimality principle demands that annotated tuples must contain minimal information, which cannot be subdivided into smaller pieces of information. No argument should contain information about 2 different entities if this is true for both, and no tuple should contain more than 1 piece of information about an entity if these can be divided. Examples are provided to illustrate this principle, including separating information if and only if it is also true when separated. Lastly, the exhaustivity principle emphasizes that all the minimal information present in the sentence must be included in the annotations. This principle ensures that no significant information is omitted during the annotation process. The open information extraction (OI) task aims to extract and categorize information from sentences into triples, adhering to principles of minimality, exhaustivity, and relation completeness. Minimality is demonstrated through examples that break down sentences into their constituent parts to ensure no unnecessary information is included. For instance, the sentence, "The group was created in 2020 by 3 people," is reduced to triples that capture its essence without excess. Exhaustivity is crucial, as it ensures all relevant information is captured. An example illustrates this, showing how Tokyo's population is over 13 millions, can be summarized into a single triple. Relation completeness emphasizes that relations should not contain information that changes their meaning. Examples are provided to clarify this principle. The page also touches on CO reference resolution, stating it is not performed with an OI, as it is intended for isolated sentences. An example illustrates how the pronoun he cannot be resolved without additional context. In the realm of natural language processing, the open information extraction (OI) system plays a pivotal role in identifying and extracting factual information from sentences. This process can be complex, requiring inference to accurately capture the intended meaning. A prime example of this complexity is the relation completeness task, where a sentence states that Chili Gonzalez, a Grammy-winning Canadian musician, resided in Paris for several years before moving to Cologne, Germany. The task at hand is to identify the subject, object, and relation within this sentence. Another example illustrates CO reference resolution, where pronouns are replaced with their corresponding entities in the sentence. For instance, in the sentence about J.7 combining tax reductions with increases in indirect taxes, he refers to J7. Inference also plays a crucial role in extracting factual information, particularly when it is directly implied by the sentence. However, it is essential to differentiate between light and heavy inference. Light inference involves simple logical operations, whereas heavy inference requires more reflection, external knowledge, or generalization. An example of light inference can be seen in the fact that Jason Charles Beck, a Jewish Canadian musician, was born in 1972. Heavy inference, on the other hand, would incorrectly infer that Gonzalez is Jewish due to his parents being Ashkenazi Jews who fled Hungary during World War II. Finally, reformulation is another key concept in natural language processing, where a complexly expressed relation or argument is simplified into a more straightforward fact. This is a compromise between collecting all factual information and formulating these facts in simple language. Overall, this page delves into the intricacies of natural language processing, emphasizing the importance of accurate extraction and interpretation of factual information from sentences. This section of the research paper delves into the open information extraction task, focusing on the development of the BenchIE FL reference matching function. It outlines several principles that dictate which pairs of extractions made by systems and annotations should and should not match, ensuring accurate information presentation in the format of sentences and their corresponding clusters. The guidelines presented include the necessity for exact matches between two identical extractions, and the importance of maintaining relation specificity in the context of the extraction. This is crucial as the relation is the vehicle of information, and thus, it needs to be as specific as the reference. The example provided illustrates how a different formulation that is just as specific should be accepted, while irrelevant relations such as was thrown are not considered relevant in the context of the extraction. Additionally, the section highlights the importance of including grammatical corrections in the clusters, ensuring that neither the systems making the correction nor those using the original text are penalized. This is demonstrated through the example of newspaper and newspapers, where both the original and corrected tuples should be included in the same cluster. The paper also addresses the issue of active and passive voice, stating that clusters are used to group together the active and passive formulations of an extraction in a single fact. If the active formulation is not present in the text, it should still be added in the same cluster if it is simpler than the original formulation present in the sentence. An example of this is given, where the active and passive voice of the sentence, "The apple was eaten by Kyle," are included in the same cluster. Lastly, the paper touches upon the topic of attribution and speculation, emphasizing the need to include this information in the relationship as it is formulated in the sentence. This preserves the information without introducing a particular structure. The example provided shows a case where the attribution is added in the relation of the tuple, demonstrating the importance of maintaining this information in the extraction process. In summary, this section of the paper provides comprehensive guidelines for the open information extraction task, focusing on the importance of exact matches, relation specificity, grammatical corrections, active and passive voice, and attribution and speculation. These principles are crucial for ensuring accurate and precise information extraction in the development of the BenchIE FL reference matching function. In the context of relation extraction, errors in syntax or grammar can alter the meaning of the relation or its arguments, rendering the extraction invalid. However, if the error does not change the meaning, the extraction is still considered a match. In terms of word choice, equivalent words not present in the reference annotation are accepted if used in system extractions, as long as the context remains the same. Similarly, incorrect word choices are tolerated if the underlying meaning remains intact. When evaluating the level of detail, extractions with higher detail than the annotation are considered matches if they convey the same information. This involves combining information from two annotated clusters. However, extractions that combine data from 3 or more clusters are deemed too noisy and imprecise to be useful.